Hey there, I'm going to do a little analysis of my lighthouse photo, which I call my white swan, or black swan, or whatever. It's some of my own personal evidence the Earth is curved. And while I talk, I'll show you some of my attempts at filming the lighthouse tower. But first, why I call this photo my white swan. We all love analogies. They're a simple way to help us explain and understand more complicated concepts and make them relatable. I was going to do a whole thing here about the history of the black swan analogy, but if you're interested, look up the original black swan theory and where it comes from. It's actually pretty interesting. Oh, I'll put a link to the Wikipedia page in the description. So, as usual, flat earthers have completely misunderstood and misrepresented the black swan metaphor. Now, if I understand it correctly regarding flat earth, and I'm sure I probably don't, globe earthers say only white swans exist, the globe. But if a flat earther produces evidence of a flat earth, a black swan, then white swans don't exist and the earth is flat, or something like that. They think this photo is their black swan. This platform should be well over the curve of the Earth, and in this photo it's not. But it's just a significant amount of refraction causing it to look like this. But keeping to the analogy, I think it's just a white swan with mud on it. Because, as most of us know, this is what the same scene looks like in regular, calm conditions. So, my photo. This is Sugarloaf Point Lighthouse on the east coast of Australia, photographed from Lehman Street Car Park, Nelson Bay, at an elevation of 65 feet or 20 metres. I've also photographed the lighthouse from two other elevations, but for now we'll just concentrate on the 65-foot location. Now, for the diligent flat earthers out there that love to check the curve calculator, they'll notice the lighthouse shouldn't be visible. That's because it usually isn't. I've got tons of photos and video with no lighthouse. I have to wait until there's a significant amount of refraction before I can even see the lighthouse. And I know when it's zero refraction and not weather conditions preventing me from seeing the lighthouse, when I can also see the light from higher elevations. Now, thanks to a flat earther that attempted his own analysis of the photo, here, you can pause on it if you want. I'm not reading that crap out. But because of this, one of our friends from Twitter and YouTube, KC, has given the photo the math teacher treatment, so let's take a little look at her analysis. The camera is 31 miles from the lighthouse at an elevation of 65 feet. The standard globe dimensions would determine there should be a maximum of 298 feet hidden at 31 miles away. The focal height of Sugarloaf Lighthouse is 258 feet, the height of the light. There's another 16 feet above that, determined by the incredible pixel analysis she's done on a close view, making the elevation from sea level to the top of the lighthouse 84 meters or 275 feet. So technically the lighthouse is 23 feet under the geometric horizon. But this does not include terrestrial refraction. It's obvious when analysing both photos that the lighthouse has been stretched, and she's made this really effective comparison just here. When we scale the lighthouse by width, the lighthouse is far too tall and misshapen, so there's been a vertical stretch of the image reaching my camera. And yes, the lighthouse is easier to photograph when the water is cooler. Unfortunately, the last two winters were bust here because we had these little fires that were burning for about a year. Anyway. But this winter, it's game on because when the water is cooler, it cools the air, causing the atmosphere to be denser at the surface. Light is then bent down as it passes through the gradient in the atmosphere. Because when the light bends down, images appear higher than they should, but not perfectly or consistently because atmospheric density layers are volatile. Which is why I have dozens of photos with no lighthouse, even in clear conditions. And Casey's conclusion is, there is no reasonable explanation for why the entire amount of land under the lighthouse is not visible in this photo if the Earth was flat. None. And then she's given us some of her own corresponding and supporting evidence and asks, can refraction lift the lighthouse the 20 meters or so needed to give us the view? And she's provided one of her own images of Toronto, Canada on 2 different weather days. The domed roof of the Rogers Centre reached much further up the CN Tower than it should, at least 20 meters of lift. And as we can see, the photo on the right was taken on a day with a cooler water temperature, giving the scene a significant amount of refraction to raise the dome, thus proving that refraction can lift something like a lighthouse just high enough above the horizon for us to see it. Also, our friend Fred here calculated the angle needed to lift something by 20 meters at a distance of 50 kilometers. We know the sun and the moon experience quite a lot more lift than that to match our observations, 21 times more in fact, so this little bit of lift is peanuts by comparison. So this winter I plan on getting some better footage and photos of the lighthouse. A huge thanks to all of you for watching, commenting, subscribing and liking these videos. A massive thanks to my patrons. Thanks to their help, I'm another step closer to doing these Southern Sky live streams, which I absolutely can't wait to do, and see if we can show these flurfalots the Southern Celestial Pole live. Anyway, take care out there, stay warm, see ya.